Hi, I'm Bob Lefferts. Welcome to episode 8 of Missile Command, How to Make Your Own Video Game. This is the last program we ended up with in episode 7, my Paint program. And today we're going to start a new program and actually learn about object-oriented programming. So what we're going to do is we're going to go over here and right-click and say New Python File. And the name of the Python file is going to be frog hop. I'll do camelback frog hop as a Python file, and that gives us a new file. I'm going to move that file over here on the side so that I can see both the new file as well as my paint. I'm going to copy the lines from mylib down to this point so we can start basically with the same infrastructure at the top. So I do a mylib import. I don't need this tkinter. TKK, we're not going to use that object. So I import mylib, I create a window, I set the size just like we did before, create a frame, put the frame at the top, create a canvas. Instead of black, I'm going to use white, and down here in the color range, instead of white, I'm going to put in black. Okay, I don't need this undo function anymore, but I do need an image of a frog. And so I'm going to call it frog PNG equals. And what you're going to do here is we're going to do photo image of file equals images and sounds, which is the folder over here on the left. There's a folder over here on the left. Images, sounds, and then inside of that, we're going to do frog.png. And what this is going to do is it's going to convert this PNG into a photo image that we can actually use on our TK canvas. And that'll be helpful. And then the other thing which I want to need to add here, so let me give myself a little bit of space here. So I'm going to create the frog for the PNG, and then I'm going to go down here at the bottom of our paint program and grab this distance function. So we're going to grab and put on into the top frame, we're going to add the ability to change the distance. Okay. And then I want to copy that frame, duplicate that line, and this wants to be a delay string. So this is going to be delay in milliseconds. And I think I'll start here with 50 instead of 30. These are strings, so I put the string there on here. Remember to convert them into integers when we actually use them. And then when I click, I'm going to create a frog by going to the canvas that we've created up here, and we're going to create an image instead of a line or anything else that we did before. And we're going to place the image at X and Y, which is where we clicked, right? So I've got a click event like we had before. I get the X and Y from the event. So when I click, I get an X and a Y. And then I have to give it what image I want to use. And the image that I want to use is frog PNG. So when I click, I should get a frog. So let's do this. Canvas bind. Actually, I can steal it from over here. Canvas bind 1. We're going to go to click. So we'll copy that and paste it over there. So canvas bind button 1 to click. And then, of course, we need the main loop from the other program. So I go down here in the bottom and I say main loop. Now, let's go ahead and move this frog hop over to the side because we don't need the other one. Whoops, frog hop goes on. Put it right there. So I've got frog hop. I've got the paint program here. I've got mylib that we're going to be what we're using, and then I've got frog hop. So here's what we've got. Got a very short little program. Let's go ahead and run it and see what happens. It creates a window. I've got a distance and a delay, and when I click, something goes wrong. X is not defined. X, Y. All right, let's try this again. oh, x, y is a tuple, and I wanted to do this, x, comma, y. All right, let's try that again. I right click and say run, and I get a canvas, and I click, ooh, and I get a frog. Every time I click, I get a frog. Well, that's nice, but the name of this program is frog hop, so we need it to move. I want the frog to move. So what we're going to do is, after we place the frog, then we're going to get it to move, and we need a function, hop, okay, where we're going to give it the frog, and we're going to make that frog move. And in order to call that function, we're going to basically say, look, on the canvas, after, and we're going to grab the value of the integer of the delay string. So remember how we get this? We do delay string dot get its value, convert it to an integer, and then we're going to call hop, and we're going to pass it the frog variable. So what happens is when we create this image on the canvas, we get a number back. Remember how the canvas has just a number for every object on it? And then we're going to say, okay, after our delay, which we set to 50 milliseconds, we want to call this function hop and tell which object on the canvas, the frog, we want to actually move. So now we have to do the hop function. So the first thing we need to do is we need to get the x and y back. And we're going to get that by doing a canvas, get the coordinates of frog. So the canvas knows the object that was created on the canvas, give us an integer, and then we just get the coordinates from that thing. So we've got the x and y value. Now we're going to then calculate the new coordinates by using our function that's in our library. So we'll say x new, y new is equal to, and we'll use move d in direction a. Now the distance is going to be the integer of the distance string dot get. So we got the value that was on the GUI that was going to default to 30, turn it into an integer. That's the distance we want to go. And then we need to give it an angle. So we're going to use rand range. And we're going to go from 0 to 360 degrees every degree. So that's the angle. And now we need to give it the point, which in this case is x, y. So that will calculate a new xy. So we're going to then move the frog to that new xy by doing a canvas towards of the frog, and we're going to change it to x new, comma, y new. So that will move the frog. And then I want to duplicate this line, Control D, Control Shift down arrow. So after we move the frog, then we want to wait for the delay and then call the function hop and move the frog again. Okay? So we're going to click. We're going to get the event where we clicked. At that location, we're going to place an image. It's going to give us a number. We're then going to wait for the delay, 50 milliseconds in this case. And then we're going to calculate from the current position. We're going to move the distance that we want to move, which is 30, in a random direction, and calculate the new point and move the frog to the new point, and then do it again. Repeat, rinse and repeat. So let's give this a try. Run frog hop. No errors. Everything looks good. I'm going to click, and look, I get a frog to move randomly. It's moving by a distance of 30 every 50 milliseconds. And if I click again, and it wanders around, and this guy wanders around, and this guy wanders around, and that guy wanders around. But one thing you'll notice is since they're moving randomly, they can walk wherever they want, and they can walk off the canvas. And that's a bit of a problem, because then we can't see them. So how about we bound the frog, so as it's hopping, we bound it so it can't leave the canvas. And the way we're going to do that is when we calculate the new point, we're going to need to know what the x max and the y max is on the canvas. And we can get those values by getting the integer for x and the integer for y of the canvas dot win info width for x and canvas. So I get the height of the canvas and I get the width of the canvas, and I turn those into x and y. So now I have the maximum value. And before I move this thing, I need to clip x and y in. So let's call x clipped and y clipped. And what we want these to be, again, it's going to be a tuple, so there can be two of them. And we're going to do is we're going to say that we want the minimum of x and x max. So if x goes larger than x max, we're going to get x max. And we want to say the minimum of y and y max. So now we've clipped it, so we can't go past the maximum. But what about the minimum? So what we want here is that we want the maximum of x or 0. So if x ever goes less than 0, it's going to give us 0. That's going to clip the x value. I have to do the same thing here. Min of y, max of y or 0. That way it gets clipped, so it can't ever be less than 0 or greater than y max. And now what we're going to do is we're going to go and change the location to the clipped values. Let's go ahead and see how that works. Very short little program. I click. Oops, I have a typo. Oh, this is not x. That's where it was. It was at position x. Sorry. I want the new value. The new value of x, the new value of y. Otherwise, it was just sitting where I had it. I had it stuck. So let's try that one more time. Run the program. Now it moves. When it gets up, I'll start one up here at the edge. You can see that it gets clipped. It doesn't walk off the page anymore. So that's nice. And I can make as many frogs as I want, and they're all going to move, which is nice. But, I'd like to see the trail that the frog moved on when it's hopping. Now, I can actually go in here, by the way, and I can change this to a 200. And then what happens is only every 200 milliseconds do they move. So they're moving a lot slower. So this is the delay between how much they move. And this is how much they move. So if I make this number bigger, let's say 100, I can't see where they're moving because they're all jumping randomly 100 pixels on the screen, and I don't know where they were. So I'd like to draw a line when they move. So what I want to do here is when they're moving, after I move it to the new coordinate, then what I'm going to do is I'm going to do a line, and I'm going to draw a line from where they were to where they now are. So canvas, create line, okay, and it wants to be from where we started, x and y, to where we're going, which is x clipped and y clipped, and that should give me a line. Let's see what happens. Oh, so now I'm drawing a line as the frog moves. And if I draw another frog, it's also drawing lines. And you can see where it went. And if I change this to 200, you can see that it's jumping quite a bit. And it gets to be pretty complicated to see which frog is which. So let's say we wanted to have the trail that the frog went on get limited in how long it can be. And I'd like each frog to draw a different colored line. But I have no way to keep track of all this stuff because I have each frog is a number. So let's actually see what happens here. I'm going to print out the number of the frog. So when we make a frog, I'm going to say print frog. Okay? And so now when I run this program, I'm going to slide the window up so we can see the print function at the bottom. And when I click, right, the first thing that happened is I drew the first object on the canvas, the number 1. Now when I click, it's 126 because of all the lines that got drawn. And it's a lot more lines. Now if I click again, it's 321. So every time I create a frog, I have no way to know which color to apply to each line as I draw it. So I need to save a bunch of information along with the number of the frog. So let's go ahead and kill this. And what we're going to do is we're going to add the ability to add all the attributes of the frog that we want. So we already have the distance and the delay. And I'm going to hit here and I'm going to hit Control D. And I'm going to add the ability to change the path line. And again, it's a string. And then I'm going to hit Control D and the path space. And then Control B, the path color. Control D again to duplicate, and then Control the width. So the width of the path, the line and space we use for dashed lines, and then we'll add the color. So all this information we're going to add to the GUI. And we have to change the names here. So this is no longer delay string. This is path, line, space. This is all about the path. So space, color. Actually, I think what I'm going to do is not add the color. I'm not going to type the color in. I'm just going to let it pick the color randomly. So I won't add color, but we'll add the color attribute. We'll make it go random. We won't actually add it to the GUI. And then this last one here wants to be width. Width, and I want to default this to 1. I want to default the space to 0, and default the line to 10, for example. So we'll be under the line space. The line space gives us either solid lines or dashed lines. No space is going to be a solid line. And then we're going to add the width. Now we have to be able to add the properties that we're going to save with each of the frogs as we create them. So when we create a frog in the canvas, given that frog number, we're going to have to add all this information about the frog. And so we're going to put that in frog data. And that's going to be, we're going to store that in a dictionary. So the dictionary, the lookup value in the dictionary is going to be the frog number. And then we're going to get all the information from the frog data when we create the frog. So this is the old school way of doing it. And after we've done it this way, you'll see how people came up with the idea of making objects and object-oriented programming. So we're going to go in here, we're going to create a frog. And when we create the frog, I won't print it anymore. We need to set frog data. We're creating an element in frog data for the frog. And that is going to equal a new dictionary. And then we're going to duplicate this line. And we're going to say frog data of, and now we're going to put in here distance. So each frog is going to have its own distance. We're going to set the distance in this case to the distance string, get the value, and we're going to set that to an integer. All right, going to convert that string to an integer. So we're going to convert the string that's in the GUI for the distance that we want to go. We're going to store that in the frog data under distance. Then we're going to duplicate that line, and now instead of distance, we're going to put in delay. I'm giving them names in the dictionary because it's a dictionary of dictionaries. So the dictionary for the frog has other words in it. That second dictionary, distance, delay, and here it's not going to be distance string, but it's going to be delay string. Okay, so that gives me the delay string. And then I'm going to add the path line. So this is going to be line. I'll just call it line, take out the word path, call it line. And this is going to be path line string. We're going to duplicate that. And then when we create the frog, we're going to set the space. It's going to be path space string. And then we're going to finally set the width of the path. is going to be path width string. Okay, so that sets all that information in frog data, which is a dictionary. We can look it up later to see what we want to do. Save all the information when we create the frog on the canvas. So now when we go down and we draw the frog, we're going to use this global variable once we have the frog number, which is passed in on the hop function, right? And we're going to then move this distance. This is not going to be the distance that we move from getting it from the GUI, but instead we're going to make this be, the distance wants to be frog data of frog of distance dist. So that's the value we're going to use. We're still going to pick a random direction, right? Random angle, so that's fine. And then we're going to draw a line. This is going to be the max value. We're then going to get the new value, clip it. Now, when we create this line, okay, we have to check to see if the space is there. So if frog data of frog, if this frog's space equals 0, okay, then we're going to create this line. Otherwise, duplicate this line and shift control and move it down. So when the space is 0, we'll create a solid line, and when the space is non-zero, we'll create a dashed line. The first thing that we need to do is to set when the space is 0, we just need to set the color. And I forgot to pick the color up here. So we don't have a color entry, but we can use the random choice of colors. So what I'm going to do down in here is I'm going to say, look, let's do this, take this thing, duplicate it, and make this color. So now the color of the frog, and here's where we're going to use a random, so random choice of colors. So we're going to pick the color of the path randomly when we create the frog. And then down here, we're going to add fill equals, and now we're going to do frog data of this particular frog color for doing the fill. And then that's it. We're going to need to add this to the bottom guy underneath. So we'll take that with a copy and a paste. I forgot the comma. And then down here, we're also going to say that we're going to add a dash property, and dash is going to be equal to frog data of this particular frog, and we're going to do line frog data of frog of space. So if I did that properly, there should be one other one around here, and that closes that guy, and then we're good. So what's going to happen is when the space is not 0, then we're going to draw a line followed by the space. And I'll show you how that makes a dashed line. So we're setting the color, we're setting the width. Now, the last thing we didn't set was we need to set the width. Comma, that's a comma, sorry, comma. Width equals frog data of frog width. Right, so we do the fill, we set frog data of color for the fill, we set frog data of line for the dash, so we have a line and space, and then we have frog data of the frog for the width, and we set the width of the wire, width of the line. And this width, by the way, we need to copy this width and add it up here, so we're setting the width when we're only setting color and width without a dashed line. That's how the line creates. Then we create the line, and so we're using all the features that we got from the GUI, all the width, line, and space, and we're creating it, and all the data and how to draw each frog is being saved in a dictionary that we're looking up the frog number, and then getting the attributes when we draw the line. So let's go ahead and give that a shot and see if that works. So again, this is the conventional way without using object-oriented programming where you push all the information about the frog into a dictionary. Let's go ahead and see if this works. We might have made some mistakes. Looks like we made some mistakes. Line 43. I think I'm missing a colon at the end of that line. So let's try that. Okay. So when I click, ooh, look at that. We have a problem. All right, let me give myself some more room here. Oh, look at that. I typed dis. I didn't type it correctly. Let's put that as dist. That was supposed to be distance, not dist. Let's try that again. So now when I click, I've got the frog running with a 30 distance of 30 every 50 milliseconds, right? And it's got a space of 0, so it's a solid line. And if I go here up and I change these parameters, let's say I want to make this 100. Let's change the path width to 1 and 1 with a width of 4. As I click over here, so it's going 100 pixels instead of 30. So it's moving quite a bit faster, but it's got a colored line and a much fatter tail. Now, in all cases, the path that the frog has walked on doesn't get cut at any point, right? It's very long. It's going to be really long, and the screen's getting full of wires. What I'd like to do is I'd like to remove the path that the frog's gone after it's stepped 5 or 6 or 7 times. So what we want to do is we want to limit the lines and remove old lines so you can see where he's walked recently. So let's go ahead and update the code with that. So what we're going to do is when we create the frog, we are going to take frog data of the frog, and we're going to create an entry in the dictionary that is the path itself. And what we're going to do is we're going to say that is just a list. And then what we're going to do is after we create the line in the hop proc in the hop function, then we're going to say is that frog data of the frog of the path and append the line to the list. So this basically, we create a list up here and then we append each line as we draw it to the path. And the trick now is if the length of frog data of path, that's a list, if the length of that list is greater than, and now what we need is we need to know how long we want to make the list. So I'm going to go back up here and do a control duplicate and say path length. We're going to call this the length. And I'm going to say the length right now is going to be 10. And down here we're going to say if the length of the path of the list of paths is greater than path length dot get, and then I need to make that an integer. So if the actual number of lines that we've drawn as the path the frog has gone on is greater than the variable that's going to be on the GUI for the length of the path, if that's true, then what we want to do is we want to go to the canvas and we want to delete this list. So this is a list of elements of the lines that we've drawn, and it's the number actually on the canvas. And what we want to do is we want to delete the one that's at the beginning of the list because the list is getting too long. And so what you do is you put this in here, that array, and then I want to pop element 0. Okay? And that will take the first element off that list and pass it to the canvas to delete it, and then the list won't get any longer, and so the tail shouldn't grow. Let's give that a try. And now when I click, I get my line, but notice it only gets 10 long. It only gets 10 paths long, and then the last element gets deleted as it goes, which is kind of nice. And so now I can put in here, let's say, a space of 1 and a length of 1, the line of 1 and a space of 1. That should give me a dashed line with 4 and let's say a length of 20, and let's make this go a little farther. Let's make this go 100. And so now I'll start a frog that's going to inherit all these values. It's going to move 100 with a one line, one space, dashed line with a length of 20. And if I put it over here, you see that it's a much larger distance that it's moving. It's moving 100. And it's got 20 lines before they get deleted. Now the two frogs are kind of on top of each other. Let's try slowing down the frogs. So if I change this delay to 200, okay, so what's happening is the frogs got slower because we're looking at the field of this for all frogs on the canvas. We didn't use the delay parameter. So let's go ahead and fix that. So I'm going to kill this. And we had a delay parameter for the frog, but notice in the hop function, we're getting the integer of the value on the canvas, the delay string get. This should be, the delay should be set to frog data of the frog of delay, and that's how many milliseconds we want to wait. And so now when we do that, we should be able to speed up and slow down the frog. So let's give that a try. So I hit the play button. Now I'm going to start a frog here. It's going 31 with the same length that we had before, so that's fine. And now what I want to do is I want to have a frog that goes a lot farther, let's say 100, but I want to go slower. So let's do it 200 milliseconds. And let's give this a line, a 2 and a 2 space with a width of 4 and a length of 20. And so now what happens is it's going 200 at a little bit slower rate, and it's got 20 paths before it starts chasing its tail and the paths start getting deleted. So we now have the ability to draw frogs with different delays. Like I could put a 10 delay in here, that's fast, and let's say move 50, so it's going to be pretty fast. Let's give it 20 for the line and 2 for the space, and a width of let's say 2, and that is going to move very quickly because it's only got a 10 millisecond delay. So it's moving quite rapidly. It's got a length of 20. So you get to basically decide how you want to define these. And each frog gets its own data by looking at the array that's in here that's called frog data. So I want to be able to print the frog data array so we can look at it. So what I'll do is I'll go down here and I'll duplicate this line. And on button number 2, I'm going to call a function dump. And then I'm going to go to define dump. It's on a button click, so it needs an event. We're not going to use the event. And all we're going to do is we're going to do a print of frog data, that array. Okay? That's what we're going to do. Let's give that a try. So I hit run. I create the first frog. That looks fine. I'll change the line width to 4. I'll change the distance to 100. I'll change the delay to 200. And I'll start another one over here. And then I'll do another one with a 10 and 10 space and start that over here. And now when I use move this up, when I use the second mouse button click, you can see that it printed the array. So let's go ahead and kill this and take a look at what that array looked like. So the first frog is the first entry in the dictionary, had a distance of 30, a color of blue, a delay of 50, a line of 10, a space of 0, and a width of 1. And here's the path. These are the object numbers of the lines that were drawn on the canvas. Okay? The first frog was number 1, right? 1 colon, and this is the value, and this is the value of the dictionary. And then we come to frog 222. So the device on the 222nd thing we drew on the canvas had a distance of 100, a color of orange, and so you can see, right? And then we get down here, there's its path. And its path are all these 500 numbers. And then we get down to frog drawn at 363, right? So that was the 363rd object was the third frog and all of its value. And so all of that's stored in this one location that's in the memory location in the memory in Python of frog data. And so it's got you look up the frog and then all of its data, and you can see the data is nicely called by names because it's the dictionary entries, delay 50, as opposed to, the fourth one over, you won't be able to tell what it was. So this is how you would normally do it if you're not using object-oriented programming. So in the next episode, we're going to actually go in and look at how, instead of using a dictionary up at the top, a global dictionary, and defining all the different values we want with strings inside of the dictionary, how object-oriented programming flips it around. And instead of having an object on the canvas with all this data associated in a dictionary, is to create an object that literally is a dictionary where all the information, the variables, and the procedures and everything are hiding underneath that dictionary entry, so that the programming language, Python itself, can be much more helpful in knowing what the variables are, what the functions are. You have an object that's literally a pointer in memory that you then operate on. Instead of calling a function, it's called a method, methods that operate on your objects. And it's much cleaner to read, much easier to inherit properties, and to make very complex programs very simply. And we're going to need that when we start building our missile command game. So the next episode, let's turn out, instead of using dictionaries that you can see, we're going to hide all that function into a class, which is what they call it in Python. So we're going to transform this into a class in the next episode. Thank you.